Four charges are arranged as shown in figure. A point P is located at a distance r from the center of the configuration. Basically, there are four charges. This is minus q, this is plus q, and this is again minus q, and here it is plus q. So it can be considered as if there are two electric dipole placed perpendicular to each other. So four charges are arranged as shown in figure. A point P is located at a distance r from the center of the configuration. This is point P placed at a distance r from the center of the configuration. Assuming r much greater than small l, the angle field vector makes with the x-axis. X-axis is this horizontal line. So as I indicated earlier that we can assume this system as if there are two electric dipoles placed. One is this and other one is this way. As we know that direction of electric dipole movement is always from negative to positive. So these four charges can be considered as two electric dipoles, and electric dipole moment of each of these charges of each of these two dipoles will be Q into L, because electric dipole moment is charge multiplied by distance between these two charges. Okay. The point P is somewhere here, which is very far away from the center of the system. Don't go by this particular diagram. This point P is far away from here. So as we know that in case of the dipole electric field on its own axis, we know that electric field is along the dipole moment vector and is given by equal to 1 upon 4 pi epsilon naught into 2 times the dipole moment divided by distance from the center cube, 2p upon r cube. So this is the formula for electric field on axis of a dipole. Here P is QL. And for this particular dipole, the location is bisector, angle bisector, perpendicular bisector. And on the perpendicular bisector, the net electric field is always opposite to the dipole moment. So E2, because of this particular dipole, must be downward. Okay. And the value of E2 will be what? E2 will be 1 upon 4 pi epsilon naught into P divided by R cube. So net resultant field will be the resultant of these two vectors. So here is the resultant field which makes an angle, suppose theta, with the horizontal. This is net field. Below the x-axis is the choice. So this one and this one are only possible options. So theta, tan theta, here you can see is E2 divided by E1, because this is E2. Tan theta is equal to E2 divided by E1. This horizontal one is E1. So E2 divided by E1, E2 is half in comparison to E1, so it becomes 1 by 2. So theta is tan inverse half below x-axis. So option A must be the correct option to this question.